Hi, okay, welcome to our second session on circle theorems. Going to introduce you to the remaining 5 that we need to learn. It will follow the exact same format as the last session, so no surprises at all. And again, we start with our recap, the normal thing. So if you can hit pause, have a go at these questions and hit play when you're ready. Okay, here are our answers. There you go. I think the best thing to do here is, again, I think hit pause, have a really good look at what you've done, compare it to the workings out that I've done, and then I'll just point out a couple of things and then we'll move on. So hit play when you're ready. Okay, I really wanted to point this one out more than any other. This is quite different. It would have been hard. So if you found it hard, that is fine. What we're trying to do is develop our ability to apply our knowledge. If we are learning how to answer questions, we're limiting ourselves. We are waiting to see a question we recognize so that we can do it. If we learn our maths like that, we will cap ourselves and we won't make the most possible progress that we can make. So it's really, really important that we're not all about, if I can see this question, I'll be fine. It's got to be, I've got this knowledge and I have to know when I can use it, when I can apply it. And this is a perfect example of this, because there isn't anything in this question that you can't do. It's just knowing how to pull it all together. So what might you do with a question like this? You might think to start off with, it says solve. And with a quadratic, I would normally get it into this form. And then once it's in the brackets, I can start finding my solution. So here, this would suggest that x is equal to 2. However, if I did that, I would get an x equals for this bracket, an x equals for this bracket. I'd get another one for this one and another one for this one. That would give me 4 solutions for x. And that should straight away ring alarm bells, because there's only 2 solutions for a quadratic, not 4. So at this stage, I'm like, well, that can't be the right thing. I might also notice that it does say solve, and I know that this is a way to represent a quadratic. To solve a quadratic, it has to equal 0, and this doesn't. So that might be something that you spot to go, I need to do something before I can start trying to solve this. I am going to have to expand so that when I transfer this across, I can easily take the terms away and end up with the quadratic that I do need to solve. So that's what went on with that particular question. I just went on and factorized it after that. With these, I just wanted to point out that I'm always doing my check. Can I factorize this? So 5 times 1 is 5. I can't find factors that's going to make me 10. So it's quadratic formula. Over here, 6 times 9 is 54. I can find factors that will help me make my 15. So I factorize this one. If you didn't spot the pair, you might go straight into quadratic formula. It's absolutely fine. It doesn't matter. Whatever gets you to the answer, is all we want to do. So if you used quadratic formula and you got x equals -3 and x equals 1/2, you're absolutely 100% correct. There's nothing in that question that tells you have to factorize. If it said solve by factorizing, then you must. If you did quadratic formula, you'd get no marks because you haven't done what you were told. So always read the exam question carefully. But for my question, it doesn't say anything. So you can do it any way you like. I think expanding brackets now, was just something we practice so that we don't make silly errors. It's very, very easy, especially with negatives, to make an error and it throws things out. So we're practicing that now, a session, so we just get really, really good at it and really, really confident. But I would imagine we're probably there now. The simultaneous equation, I think it was a fairly straightforward. The fixed amount means that it's just going to have that one value plus whatever they're talking about. So hopefully that didn't put you off setting those up. Once they were in place, they were really straightforward to solve. Okay, here we go. First 8 circle theorems, okay? Because they link nicely, I'm going to produce these circle theorems the first three, all on the same diagram. But what I want you to do is produce 3 different ones so that you are able to see each one separately and they don't all get muddled up together. So I think the best way to do this would be for you to watch all of them and then rewind. And as you're re-listening a second time, you are making your individual diagrams to go with the rules. Okay, so I would really encourage you to do it that way round. So let's start off. So our first one is that a tangent to a circle is perpendicular to the radius. Okay, so we're going to try and do this as well as we possibly can. So I'm going to come up like this, and I'm just going to readjust it if it will let me, because a tangent is a line that's on the outside of the circle. It just touches the circumference and job done. So it technically touches at one point. Then the radius comes down and touches it at that exact same point. And this is where I have to hope for the best. That's not bad at all. You can see that that looks like 90 degrees. Now, we're never allowed to assume anything, but because it's a radius and a tangent meeting at the same point, I now have a 90-degree angle. So that is my first, or my fifth, I should say, shouldn't I? It's my 5th circle theorem. Okay, the next one, which I'm going to highlight separately, the next one says tangents to a circle from an external point are equal in length. Okay, tangents, plural, means that there's going to be a second tangent now. So we're going to bring one in this direction. We'll just straighten that up a little bit. There it is. So now I've got 2 tangents that meet at an external point. They meet here. So I'm going to rub out the bits I don't need. So these extra lengths no longer needed. There that is, meeting at a point. And that's a really common diagram for us to see when we're practicing our circle theorems, because it's the shape it makes. That fact, that property, that theorem just makes this shape, which means this shape comes up regularly. Okay. It's saying that the lengths are equal. So I have this length and this length now equal. Okay. So from that point where the radius meets and to that external point, those lengths are equal. So what does this mean? This means that they could, if they really wanted to, bring in a length question, like a missing edge question, if they wanted to, because we've got a fact about length. But it also means that we are creating more edges that are equal in length, so more opportunity of an isosceles thing appearing, okay? And as I build on this, you'll see even further where I'm going with this. So I am going to stick on the radius to this tangent as well, because that is the full shape that we're often given. And it then lends itself to circle theorem number 7, okay? Circle theorem number 7 is saying that the line joining an external point to the center. So here's my external point. I'm going to use the same one, joining a line to the center. Oh dear, that was absolutely useless. Let's try that again. Oh, it really doesn't want to play ball, does it? Let me see if I can lift it into position. No. I'm going to try one last time. Oops, might help if I actually switch the pen on. One last time. We know what we're... Oh, going to do it by hand. It won't be beautiful, I'm sorry. There, not too awful. Okay. So let's move that up a little bit. There we go. All right, so that line there that I've just used now splits the kind of kite shape that I had completely in half. So if I have an angle here, I also know each individual angle by halving it. And it's true here. So what I end up with is actually two congruent shapes. I know that the tangent in the radius makes 90. I know that this edge here and this edge here are equal in length. I know that that's a radius and that's a radius, so they are equal in length. I know that they share this length. So those two triangles have the exact same length. They are perfectly congruent in every way. So the edges of the triangles are all matching in their respective places, and all the angles do as well. Okay, so we've got 90 degrees here. If that was 65, that would be 65. And if that was 20, that would be 20, and so on. So those three really interlink together really, really well, as you can see in the diagrams that I've drawn. But like I say, you'll go back, rewind, listen through a second time and make your notes for each individual one. But I really wanted to do it together because I wanted you to see how they all actually, whilst it's three different theorems, they kind of all go together really, really nicely. The last one is stands alone. It doesn't link necessarily. So, oops, my daisy, where am I doing? There we go. A radius, let's highlight it. A radius bisects a chord at 90 degrees. All right, so I need a chord. There's a chord. I need a radius bisecting it. A radius bisecting a chord will obviously cut it in half, because that's what bisect means. So these would be equal in length if they were drawn a little bit more accurately. And I will always be making a right angle. So again, that's a really useful theorem for problem solving. It can halve my lengths if I've been given values on the edges of any lines. And it can give me another angle to mark up within a diagram where it's 90 degrees at that point as well. The ninth and last circle theorem I am going to do separately after we've just seen this a little bit. So we will see that in a moment. So make up all your notes, and as soon as you're ready, hit play and we'll start having a look at a couple of examples. Okay. So let's have a little look. Right, we're on another page. There we go. So this is the first one that we're going to be trying. I am going to do it in exactly the same way as yesterday, where I'm not going to talk you through any at all. You've got your notes, so I want you to go and look at those and see if you can work this out for yourself. Once you've had a go and you're ready to hit play, do so, and I'll go through it. Okay, so hopefully this one is a nice simple one, and we spotted what was going on. I've got a tangent and a radius meeting to make me 90 degrees. So I would be writing 90 degrees. My reason is tangent stroke radius. Okay, and then I can work out x by doing 180 minus 90 plus 42. Sorry, 52. What am I doing? Excuse me, let me rub that out and write the right thing. Minus plus 52. It's all going horribly wrong. There we go. We're going to start again because my brain is obviously not working. 180 minus 90 plus 52. Okay, which is basically 142, which is why I wanted to try and write 42 down just a moment ago. And that is going to give us 38 degrees. Okay, so we've got 38 degrees as our answer. All right, hopefully we're all happy with that. If I'm going to write down my reason for that, then obviously I've got angles in a triangle add up to 180 degrees. That was the last thing I used. So try and write your reasons as you go, and that will make life a little bit easier for you, or one would hope that it would. Okay, so next question. There it is. Diagrams look complicated, don't they? What I want you to do is just take a step back from that diagram, just take it all in, just literally say to yourself, right, what am I looking at? What can I see? What do I know? How can I use it? That has to be our maths mantra on every topic we do, okay? So hit play when you've given this a really good go. Okay, so this is about finding the length y, okay? So they want me to find this length y. I know that a tangent and radius make 90 degrees when they meet. So I've got a 90-degree angle there, which basically means I have a right-angled triangle with 4 centimeters, 10 centimeters, and a missing edge of y. This is a sneaky little Pythag that's been embedded into a circle theorem question. So we're going to be doing a squared plus b squared equals c squared. Okay, so I've got my a and b. I know that that is 4 squared plus 10 squared, and c is y, so that will become y squared. Y squared is going to equal 116. Root that to find y, and you will get 10.77 to 2 decimal places. Okay. If you spotted that, honestly, really well done. This is what makes circle theorems hard. Every question just feels different. So every question feels tricky until you've practiced loads and loads and loads. If, however, you spotted that the Pythag had been embedded, then yeah, good on you. Really, really well done, because I don't think that's easy. Okay, here's your next question. Again, literally, what am I looking at? What do I know? How can I use it? All right, do that and see how far you can get, and hit play when you're ready. Okay, so I know that 2 tangents meeting at a radius are equal in length. So I know I'm looking at an isosceles. So tangents equal in length gives isos triangle. Something along those lines. Remember, you're communicating with your examiner. So anything you do, try and write down as clearly as possible. Okay. If I'm looking at an isosceles triangle, then that angle there is 4x as well. So I have got 9 x's all together in there. 4 plus another 4 plus the 1 there. I've got 9x equaling 180. Okay, I want to know what x equals. So I'm going to divide through by 9. So x is equal to 20. So I know that this angle here is 20 degrees, but that was labeled as well. So I'm going to work out what that one is equal to. And 4 times 20 is 80. So that one is 80 degrees. So tangent equal in length gave an isos, and then I obviously used triangle equals 180 to set up my equation and solve. All right, so well done if you did that. So again, I'm really trying to demonstrate with these examples that they can be sneaky, okay? So here, they put a piece of algebra in, which meant you had to write your own equation to solve it. It is sneaky. They don't need to make it any harder, but they do sometimes. And we want to be aware of that, okay? So please don't worry if you didn't get that far with it. It's you're learning, so you have to be really patient, and if you did do well, great job, honestly, fantastic job. All right, so we are going to move on because we're going to have an opportunity to practice everything. Okay, so don't panic if you don't feel you've done enough yet. The alternate segment, this one is considered the hardest to learn and spot, the hardest to identify in a circle. And it's taken me, I'll be honest, a little while to learn how to teach it in the best ways to try and reduce the confusion. I do use color to help me. So hopefully you'll be able to sort of see the connections that I'm trying to make you spot. And then we've got to learn how to apply that to actual circle theorem questions. Okay. So it says it's the alternate segment. So that's all you would need to write down if you were referring to it. You don't need to write a massive amount. And it means that the angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. Okay, so let's pull a visual of all that information. So the angle between a tangent, I need a tangent, so I'm going to put that on first. So let's put one straight across the bottom, and we'll just get that in the right place. So there is my tangent. And a chord, so I'm going to put a chord in now through the point of contact. So the chord has to be in contact with the tangent, okay? So a chord, I'm just going to do a scruffy picture over here. A chord which cuts through here has to touch the tangent at the same point. So I'm going to draw a chord off in that direction, okay? So the angle between a tangent and a chord through the point of contact is this angle here. Okay, so the angle where the chord and the tangent meets, basically. Okay, now generally you are going to see a triangle coming off of here because we need an angle in the alternate segment. Okay, it's equal to another angle. So we've got to create something that's going to give me another angle that's in the alternate segment. So this is what the rest of the diagram would look like. Okay, so I'm going to come across to the circumference here, and then I'm going to come up here. This is really, really common. And actually what I've done, and we will look at this, is I've created another second chord that's making contact with the tangent. So this alternate segment theorem can be used twice over, not just once. But obviously we're focusing in on this one here. Now, this is the way I think you need to think about this theorem so you don't get confused by it, because there's a lot happening. Highlight the chord that you are focused on. So this chord here is the important chord because it's the chord with the angle. This chord also touches the tangent, but there's no angle marked. I'm not interested in this chord at this stage, okay? So this angle is touching this chord, and I have to choose the angle that's equal to it in the alternate segment. This is where people get confused, so I'm going to show you. I've got this segment, okay, which I'm not going to colour in completely, which holds the angle. And then I've got this segment, yeah? I've got two segments either side of a chord. So then I've got this, well, I have an angle there in this segment. I have an angle there in this segment. And I have an angle there in this segment. In fact, all three angles are in the alternate segment. So again, it's a bit like, well, which one, out of the three is the one that's equal? And this is the best way to deal with that problem. So I'm going to get rid of my greens. Okay, I've highlighted the chord. The angle it equals doesn't touch the chord. So this was an option because it's an angle in the alternate segment, but I can't use it because it touches the chord. This was a possible option, but it touches the chord. So I'm not going to use that one. It's this one, the furthest one away from the chord that's been involved is the one that I use. So I'll mark that one on. If that is angle X, that is angle X. They are equal. So highlighting that chord can really, really help. So if I was to now just demonstrate it using the other chord, okay, if it's this chord that we're talking about in the problem, and sometimes they do use them both, then it's that angle there is going to be equal to, not this one, because it touches the green line, not this one, because it touches the green line. It's going to be equal to this one, the furthest one away in the alternate segment. That is going to be my y, matching my other y. So I hope I've explained that well. It is a very tricky one for people to spot, and it is a very tricky one just to remember. Having taught it using the highlighted chord, I can confidently say that students have much more success in working out what they're doing. So please don't take shortcuts. Highlight your chords. It will help, I'm sure of it. So as soon as you've got your note in and you're ready to go, we will look at some examples. All right, so here is our first one. And I literally just want you to pause and just have a go. It doesn't matter whether it goes brilliantly or it goes completely pear-shaped. It's going to go how it goes. Just have a try and press play when you're ready. Okay, so I'm going to highlight a chord. I'm going to highlight this one. All right, so this is the angle that is being made with the chord and the tangent. I don't want any angle that touches that green line. So that one over there is equal to the C. So I can see that C is equal to 41 degrees using the alternate segment theorem. So that's the first one done. Okay. It's really a good idea to label up what you know onto your diagram, because again, it's helping your eyes feed information to the brain without the brain having to work too hard to get it. And I can now straight away see, having put that 41 on in that position, that I've got enough information to help me find D using just a simple straight line rule and nothing harder than that. Okay, so D is going to be equal to 180 minus 41 plus 63. Okay, that is going to equal 76 degrees. So D is 76 degrees and E is equal to 76 degrees because of the alternate segment. And hopefully you can see, I'm going to highlight it, but hopefully you can see that you've got your chord. So D is tucked in there, and that's the one that doesn't touch the blue line and therefore is equal. Okay. Try and write your reasonings as much as you can. I missed off straight line for that one. If you write it as you go, it's a good habit to get into. And that's our first one. All right, there's your next question. So hit pause and press play when you're ready. Okay, so hopefully we did our usual check of, right, what am I looking at? What do I know? And I can see, looking at this, that I have a line going through the center. All right, so you know how much I love a highlight. I'm going to highlight that and know that I have got my diameter rule to give me a 90-degree angle here. So I have got 90 degrees because of diameter circumference. Okay. I have a tangent chord angle. I can change my color. So there's the tangent chord angle. Okay. That's the chord involved. which means out of all three angles, it has to be that one because those two are touching the green line. So it has to be that one. So I now know that is 65 degrees. So I got that 65 degrees using my alternate segment. And then I'm going to finish it off by doing 180, take away 90 plus 65, which is 25 degrees. So x is equal to 25 degrees. If you got that right, really, really well done. Okay, needed to spot that diameter really to solve that question. So even if you got your alternate segment, without the diameter knowledge, you wouldn't have got any further. Okay, next question. Hit the pause button and press play when you're ready. Okay, right, let's do this. So I have an angle here that's touching that chord, which means that is the angle that it's equal to. So A is equal to 69 degrees, alternate, whoops, why am I putting a little line in there? Alternate segment helped me work that one out. So that one's good. Okay, next one, choose a different color. I've got one here, which is on that chord, which means I can't touch those two. So it's this angle over here. So B is equal to 65 degrees, alternate segment. And now C, okay, so if we mark those on, 69 and B was 65, I can see C is in a triangle with those two. So C is going to be 180 take away 65 plus 69, which is equal to 46 degrees. And all I've done there is use triangles, add up to 180 degrees. All right. Now, my communicating here is done in the shortest possible way. When it comes to your GCSE, I would be writing it in full sentences. Triangles add up to 180 degrees. I don't want to risk losing a mark because he's not understanding my code. Okay, so really, really important. Okay, hopefully we are starting to get more of this right. It's not important about being perfect yet, but it's, are you feeling like you're making progress? Are you feeling like this is starting to make sense? Remember, you can always rewind and re-watch an explanation. Sometimes it might go through a bit quick and you just want to take some time to absorb it by watching it a second time. Do that type of thing if it's going to help. It's a taped recording, which means you can watch things over and over until you're happy. All right, here's your next question. So this one says you need to write an expression for y in terms of x, and then you're going to write an expression for z in terms of x. So you're not going to get y equals 40 degrees. You're not going to get a numerical answer here. That's not what they want. They want you to label up those angles y and x in terms of x. So instead of saying that angle's y, we're going to say that angle is x. Okay? So I want you, again, just to take your time looking at the diagram to start off with to see all the different theorems that are there and which ones are going to be useful. And then start trying to apply what you know and see how far you can get. Hit play when you are ready. Okay? Hit play when you are ready. Okay, so the first one, y, is the easier one out of the two, okay? I've got my points, and from the point, I go to the center, or I can follow a couple of different lines that take me to the circumference. So this is the angle at the center is twice the angle at the circumference. So angle at center twice angle at circumference, which means if the circumference is x, y is going to be 2x. All right, so that's the first bit done. Now it says write an expression for z in terms of x. Okay, so what do I know and how can I use it? I know that I'm looking at an isosceles. So I know that, let me mark it on. I know that they are, they're both a radius, aren't they? So I've got the two radii, and that means I've got an isosceles triangle, which means that that technically is z as well. So I know that triangles add up to 180. So y has to equal 180 take away 2z. So that's an expression for y, but at the moment it's in terms of z, not x. So I have to continue working on this so that I can actually get this in terms of x. Okay. Now what I've got is I've got a chord here that makes an angle there. And that angle there, I'm going to mark it on so it's nice and clear. That angle there fits with this angle here. Okay. So I know that this angle here is also x. How does that help me? There's another theorem that I need to spot that helps me. Okay, and I've got a lot of colors going on now, so I hope I'm not confusing you too much. I'm going to go with bright red. This radius meets the tangent at 90 degrees. So I have 90 degrees here. So I can now say that z is equal to 90 take away x. I hope you're following this. This is higher than a grade 6. So if you are feeling like, whoa, this is actually really tricky, it's because alternate segment theorem is at a higher level than the rest of them. But I don't want to put this in a separate course. I'd sooner have all the circle theorems together so that you're able to learn it in one go. So it's really important that you understand if this is feeling very hard, it is. Right, let's go back to it. I have just told you that my z can be represented as the 90 degrees that the radius and the tangent makes, take away the x from the alternate segment theorem. Okay, whatever that number is, it's 90 take away x. Okay, but I've got two of those, all right, which means, and I'm going to write it here, if I've got two z's, then I've got twice the numbers, and I've got twice the x. I've got double everything, yeah? So I've now written, I hope we can spot what I've been up to. I've now written 2z, which I've written here, in terms of x. So I can change what I've got here now to write y equals 180 take away all of this. Now, when I have to take away more than one thing, there's two terms there. Whenever I have to take away more than two things, I'm going to put it in a bracket. I'm going to say it's 180 take away all of 180 minus 2x. Now I'm going to do what I can see, okay? There's lots happening in this, all right? I have a minus squashed up to the 100, to the bracket. So that means I've got to multiply the bracket out by a -1. So there's an invisible 1 here, okay? That's going to give me 180 minus times 180 minus 180 minus times minus 2x. I've got two negatives making a positive 2x. 180 take away 180 means it's gone, leaving me y equals 2x. Okay. So that's kind of proving all the way down, okay, how everything interlinks and how everything works at a much higher level, okay. Writing an expression in terms of, for z in terms of x, we did here. So we could have stopped there, okay. But I really wanted to show you how it all pulls together and how it all relinks and just generally how it works. Don't worry if you haven't followed it 100%. You can watch it back through. As I say, it's a much higher level. So it may take a little while, but I think having circle theorems in the one place makes a lot of sense. I hope it does. Okay, here we go. We're going to try another question. All right. So I want you to hit pause and press play when you're ready. Okay, so here we go. Just take away anything that might be distracting. Okay, so I can see a diameter. Yeah, I've got a line going straight through, which means that the point it touches, the circumference, is 90 degrees. So that x is 90 degrees because of my diameter circumference rule. So I'm going to pop that on there as well. Now I can see that I've got my tangent in chord angle here. So I'm going to highlight the chord so that I go to the right place. It can't be any of those two because it's touching the blue line. It's got to be over here. So I know over here is y as well. All right. So I can use my triangle rule. So 180 minus 90 plus 52. That is going to equal 38. All right. And we've got, basically we've used triangles equal 180. And then obviously the alternate segment theorem as well, because that is 38 using the triangle. And that is 38, which is the one they wanted us to find using the alternate segment theorem. Okay. All righty. So we're going to look at some exam questions. Okay. You may feel like you need a break. If you haven't taken one already, you're feeling a little bit full up with the amount of work that we've already done, then by all means, step away, come back later, come back tomorrow, come back when you're ready, and we'll carry on looking at some of our circle theorems. So these are real past exam questions. We've got, I think we've got 4 or 5. So we've still got quite a way to go yet. So like I say, if you think, oh my God, this is too much now, take a break. Really, really important. Don't try and do it if you're losing concentration, because this requires a lot of focus. Okay, so as per normal, we're hitting pause and pressing play when we think we've got the answer. So off you go. Okay, so we have got 9 theorems that we could now choose, that we've now got to try and work out which ones are in our diagrams. Okay. I love wrapping around a given angle and coming down to the circumference, because remember, it's usually 2 points that are going to be a great starting point for trying to work out what's going on. So my 54 comes down to these 2 points. If I come away from the exact same 2 points along 2 different lines, if they go all the way to the circumference, which they do, they come out of here, then I've got an equal angle, okay? And that is 54 degrees. So they asked me to find the size of angle ACD. I have actually done that with my first attempt. So I would be putting down 54 degrees. And then it says, give a reason. So I'm either going to be really good at remembering how to put that sentence down, or I'm not. Hopefully, if you are doing it every time, every opportunity, it will come. So this is same segment are equal. That's what we've used there. So that's what we would write down. All right. If you got that right, well done. Here's the next one. So pause, take all the information in. Again, be constantly saying to yourself, what am I looking at? What do I know? And then hit play when you're ready. Okay, so I can see that I've been given an angle at the center. So the chances are very, very high that I'm going to be using that angles at the center or twice angles at the edge. So what I want to do is I just want to come down to find the points on the circle, okay? So they're here, and I'm going to go off half this, and I've got my 84 degrees. Okay, remember, let's finish this first, and then I'm going to point out an error that could be made. Okay, so that's what you do, and you've got to give your reasons. So give your reasons as you go. So I'm not going to write it down in a full sentence, but angle at center, maybe I am. I just can't think of a shorter way to do this one. Angle at center is twice that at circumference. Just gonna write that, shorten it somehow. So I've got that. Then I have got 1, 2, 3, 4 points on the circumference. So I've got a cyclic quadrilateral, and remember that opposite angles add up to 180. So to find ADC, A to D to C, which is the angle we're now on, I'm going to be doing 180, take away 84, which is 96 degrees. Okay, and to finish off, I've got to write down how I made it 96, and I used the rule cyclic quad. Okay, opposite angles add up to 180. I would want to write that in full. Okay, now I want to show you the error, okay, that people can make here. So I'm just going to rub this out. It says that I've got to find the size of angle ADC. So I should really be looking at that first of all and marking it on. That's what they want me to find. And then I'm going to probably spot that I've got an angle at the center. It would be very tempting, okay, because I'm at these 2 points, you know, how do I know I've got to go in that direction? Why not go in that direction? If I went in that direction, I think I was doing the right thing. I would have my 168 and I'd get my 84, and I'd start saying that X is equal to 84. And we've already proved that that isn't the case. Okay, so how do I know? How do I know not to make that mistake? Now, I did mention it when we were doing the original theorem, when we were first learning it. They have to be kind of under each other. That is under the center point. This is under the circumference. Okay. Whereas if I went off in the opposite direction, okay, I would be doing this. So this is under, but this is on top of the center point. So they don't go together and it doesn't work. So it's always, they kind of go, you know, they're like going to touch each other, aren't they? If I drew the arcs big enough, they would touch each other. But this one, they won't, because these lines are in the way, stopping them. Maybe that's a way of thinking about it. It's coming up with a way that works for you, but it's really important that we go in the right direction, or it can go wrong very quickly. Okay, next question. All right, again, take in as much as you can, apply it, and see how you get on. Press play when you're ready. Okay, so what have we got going on in this question? I've got tangents. They're not extended tangents, so they don't kind of go off any further, but they are tangents. They're lines that are meeting the circumference at a point. This is definitely the center, the O, which means this is a radius, and a radius and a tangent meets at 90 degrees. So I've got that happening in both places. So I'm going to mark that on. Okay. It's telling me I've got to work out the size of angle DOA. So it's important that I find that angle and know what I'm actually trying to achieve. DOA, okay, D to O to A is this angle here. So I'm just going to mark that on with a little X so I don't lose sight of what I'm doing. So I've already put some information into my diagram because I just spotted it and I charged straight on in there to make a start. Now I've stopped to think, actually, what am I looking for? I'm looking for that. Okay. So what else do I know? I know that this line here is bisecting the two tangents, which in turn means that if this is 34, this is 34. So I might as well mark it on. I also know that triangles add up to 180. So I can now say 180, take away my 90 plus 34. That's going to give me 56. So I now know that is 56, and I know that is 56. Okay. So the two angles tucked into the remaining triangles are going to be equal, 56 each. So perfectly congruent set of triangles there. I now have enough information to finish this off just using the simple straight line rule. I've got a straight line, and those three angles need to add up to 180. So X is going to be 180, take away 56 plus 56. Okay, that is going to equal 68 degrees. So X is 68. Now, when you've got a lot of working out like that to do, it's very common for them to leave you alone when it comes to reasons. If you look, it doesn't ask at all for us to write our reasons. If it did, we'd be doing it as we go, so we don't miss anything off. But if it doesn't ask, then we really don't have to. All right, next question. Okay, hit play when you've had a go. Okay, B and C are points on a circle. You've got a center point marked as well. AB and AC are tangents. And angle BOC is 130 degrees. So the first thing that I'm going to do, I'm going to try and do it with my straight edge as well, but we'll see how that goes, is I'm going to mark on angle BOC being 130 degrees. I have to work out the size of angle BAO. Well, BAO, B to A to O, requires me to pop a line in there so I can clearly see that angle. So I'm now going to add that information in. I wasn't very good at this last time, was I? Better than last time. I have to find this angle here. I know that that line is bisecting, so my 130 can now be halved into 65. I've got 65 that side. I can mark it on if I want to. Okay. I also know that my radius and my tangent are meeting to make me 90 degrees. So x is now solvable by doing 180, take away your 90 plus your 65, which is 90 plus 65. Yep, that is going to be 25 degrees. Just stop and think there for a minute. And again, I haven't had to put any reasons. It required me to put more of the lines on. They hadn't done it for me, but it was fairly straightforward because they were telling me information and the bits were missing. So I needed to add it anyway. All right. So hopefully that went well. We've got one more and then it will start to become something we see at the beginning of all the rest of our sessions. Okay. I am going to make them exam questions so that we are really working on the real thing. Okay. Right. Last one. Hit pause and press play when you are ready. Okay, so again, this is one that I would say is at a higher level than grade 6. So if it's been a tricky one, that is why. We're going to work our way through it carefully so that it's explained. Any steps that you did that were right, please celebrate, okay, because it means that you're on the right lines. If you got all the way to the right answer, then absolutely awesome work, because these questions are not easy. I know I keep saying it, but it's really important that you remember that they're not easy. Okay, so what am I looking at? Well, let's read the question first of all, make sure I know what I'm doing. R and S are 2 points on a circle, and I have a center point. My brain is already saying stuff to me. I'm like, okay, so those two are equal in length, they're a radius, blah, 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 blah. TS is tangent to the circle. So again, my brain is already telling me, okay, I've got a radius and a tangent, so I've got 90 degrees there. Angle RST, okay, R to S to T is X. They've marked that on for me, so that's what I can see. And I've got to prove that angle ROS, so ROS is equal to 2x. So that's the angle that I've got to try and give a solution to, okay? So what do I know? Let's start marking on some of the stuff that I've just mentioned, okay? I know that I've got the 2 radius here. So I've got an isosceles triangle. It may be useful, it may not. I know I've got a 90-degree angle here, which means I know that the OSR angle, so I'm going to highlight it. So this angle here, I know that that angle, OSR, is equal to the 90 degrees, take away the x. Looking familiar? Okay. Because of the isosceles situation, I know that SRO, I guess, or ORS, depending on which way around I want to do it, that is also going to equal, so let's write it down properly, SRO, that is also going to equal 90 minus x. Okay, so my ROS, the one that they want me to find, is going to be 180 minus this. 90 plus 90, 180 minus 2x. This is exactly what we saw a moment ago. Okay, this is going to expand to give me 180 minus 180. The 2 negatives here create plus 2x. They cancel out, and I've just proved that ROS equals 2x. Now, this one does say give a reason for each stage of your working. Okay, so you either have to go back through, or you should have spotted that and done it as we went along. I didn't spot it, so I didn't do it. But we've used tangent, radius. Okay, so we've used here tangent, radius, and we used here isosceles, isos triangle. Okay, and here we haven't really used a rule. We've used triangles equal 180, but we've been setting up equations on that step there. Okay, we're done. All right. I am going to be, like I say, doing exam questions. I'll try and give some variety. I'm not going to just avoid the harder ones because they're not grade 6. We want to be exposed to everything. The more practice we do, the better we are going to feel. What I'm actually going to do at the start of next session is I'm just going to do a circle theorems recap. So we're just going to sort of shelve everything else just for the moment. We've done quite a lot of practice anyway, just so we can concentrate on these circle theorems for a couple more sessions. I really want you to have that opportunity to practice. And I think the more questions you get the opportunity to do that with, the better. So expect that for the next session. But for now, honestly, it's a tough topic. Whatever and at whatever stage you're at, you are doing really well. Just keep that effort going. It will get easier and easier as we go on. All right, well done today.